Hey everybody, welcome back. This video will be a fair bit longer than some of the videos I've released recently inside of that R Basic series, and that's because this is going to serve as more of a crash course for ggplot2. So if you're new to R, just kind of getting started visualizing your data in R, you've probably come across ggplot2 and you may have run into some issues. And so I just want to kind of give a brief overview treatment of ggplot2 and what it is that you can do. Inside of this, I'll also be doing a couple of things that will make their way into the R Basic series in the future, such as dropping NAs from your dataset, renaming month numbers to month, as you can already see on the screen here, to month abbreviations, things like that that will be covered later, but hopefully this treatment will be just fine. So the dataset that we're going to use lives inside of this NYC Flights 13 package. So I'm just going to load all of these packages right now. And the data set inside of that package we're going to use is called flights. We're also going to use the weather data set, but that's going to be down the road. So I'm going to rename this as my flights. And what I'm going to do is if we take a look at our flights data set, we see that we have month and it's just the month number. I don't think that looks particularly good for visualizations. I'd much rather have the month name or the abbreviation. And so that's all I do starting here on line 9. I just take the month name. It's really a month abbreviation. And I use the month.abb function. So this actually just comes standard inside of R, and we also have a month.name. And then all we're passing into it is the individual month. And then I'm just assigning levels so that when we plot this, it orders it correctly from January to December, so that we get the actual ordering of the year. And so inside of this, my flights, that's the only column that we really add and change for now. And so let's dive right into looking at how to do line plots inside of ggplot2. So what we're going to look at for this is going to be the average delay from these 3 different airports that we have inside of the data set. And so if you're not familiar with the data set, the 3 airports that we have are going to be Newark, JFK, and LaGuardia, and these are all going to be over the course of the year of 2013. So what we're going to do for this is we're going to create a separate data set. I'm going to call this average delay DF, and it's going to work off of our my flights data set. And what we're going to do is we're going to group by the month name and the origin. So what this is going to do is this is going to give us information on the airport for a particular month. So what I'm looking for is the average delay. So I'm going to summarize, create a variable called average delay, and I'm going to take the mean of a variable called departure delay, DEP delay. And from this, we're going to also remove NA. So we're just taking the average of this departure delay here for each month across the 3 airports that we have and making sure that our number is actually a number by removing any NAs that may be present in the data set. So once we take that, we can take a quick look at what our data set looks like now. And we see that we've just got the month, and then we've got the 3 airports for that month and what the average delay time for that month for that airport was. And so let's say we have this information and we want to be plotting it. We can plot this quite easily in a line graph. So inside of ggplot, we need to pass in our data. So our data argument will just be this average delay DF. And what we can do is we can actually delete this data part. And then we also have a mapping. And this mapping is always going to start with AES for the aesthetics. And so as you can see from the tooltip that pops up, what we want to pass in here is what our x-axis is going to be and what our y-axis is going to be. So our x in this case, we want to have this as our month name because we want to track the average departure delay across these airports for each month. And then we also have our y as this average delay as the value that we calculated that we want to show. And then what we want to do is we're also going to, actually, let's hold off on that. I'll show you what this looks like base. And so we can do geom line, and then we can plot this. And so you can see this really doesn't look good at all, right? This doesn't really seem like what it is we're actually trying to do here. So we have to add a couple of different arguments to this. So one of the arguments we're going to add is going to be color of origin. And so when we do this, we get this question to us. Each group consists of only one observation. Do you want to adjust the group aesthetic? And yes, we do. So where is it that we're grouping this data by? We want to group this data by the origin, right? We want to group the data by the airport it's leaving from. And so when we add those 2 arguments, we add the group equal origin argument and the color equal origin argument, we now get this plot over here that shows the red line as Newark, the green line as JFK, and the blue line as LaGuardia. And so that's how we can easily make a line plot. And we'll go back and we'll change things like the axes labels and the titles and the backgrounds as we kind of go through this video. So that covers the basic treatment of the line graph. So the next thing we're going to do is we want to maybe look at what a scatter plot is. So the relationship between the average delay for departure and then the average delay for the arrival. And if we take a look back at our data set here, we've got this departure delay and then we've got this arrival delay. So those are the two variables we're going to look at. And just because there's 336,000 observations here, I'm going to kind of shrink it a little bit, and I'm going to call these summer delays. And we're going to take flights, and I'm not sure what the actual summer months are, but let's do summer as being June to August. And so with that, we're also going to filter so that the only airport we're looking at is LaGuardia. So we're going to add origin equal to LaGuardia. And so now we've got the smaller data set here with only, if we look at table of summer delays and we look at the month, we see that we only have 6, 7, 8. So June, July, and August for our months. And then if we do the same thing and we look at origin, we see that we only have LaGuardia. So we've got 26,000 down from the 336,000 that we had before, which is just much nicer to work with. The other thing I'm going to do here is actually drop NAs from our two columns that we had before. So this departure delay column and the arrival delay column. And just to clarify, from the two columns that we're going to actually be plotting. I ran this previously and there were some NAs there, so I just wanted to go through and do this to make sure that we don't encounter anything weird. So now we do our ggplot, and this time the data set that we want to pass through is our summer delays data set. And the mapping we want to have our departure delays on the x-axis, and we want to have our arrival delay on our y-axis, and then we want to do a scatter plot with geom point. And notice that with geom line and with geom point here, we're connecting everything through a plus sign. Just like kind of in dplyr, we use this % greater than % pipe to connect the various statements. Inside of ggplot, we use this plus sign to connect our statements. So here we see that we now have the relationship between the departure delay on the x-axis and the arrival delay on the y-axis. And so there's this really big dark grouping here. So one of the things that we could do to adjust for that and maybe make it look a little bit better is adding in an alpha. And so this alpha is going to add transparency to the individual points that we have. The closer to 1 you are, the thicker, like this would be an alpha of 1. An alpha of 0 would be completely transparent. So we're going to go on the more transparent side of things. We're going to do an alpha of 0.2. So once that loads in, which there we go. So now we can see that our points are much fainter, and this is still very dark, and it shows the intensity of the concentration of the departure delays and the arrival delays kind of within this maybe 100-minute to 100-minute box. Really is where most of them are. But we also see that we have this really linear relationship. So if you have a high departure delay, you're also likely to have a late departure delay, a strong departure delay. You're also likely to have a late arrival to your destination, which makes a lot of sense because if you were delayed in your departure, your flight still maybe say 3 hours. Now it's just going to be 3 hours plus your hour that you were delayed on departure. And now you get 4 hours. So it would make sense that those are in a nice, pretty linear relationship there. Perfect. So now we can move on from this. And before we actually do that, let's just move on right now to the individual bar plot. So for the bar plot that we have, what we're going to do is we're going to do this two separate ways. So first way, using stat equal count. And so if you're new to ggplot, that little comment there might not make much sense, but what we can do is we can take ggplot with our base data set. So our my flights data set, pass in some aesthetics, right? And so we're going to pass in again the month name, and then we're going to pass in only one argument here, which is going to be the fill, which is origin, right? So we're going to color these bar plots by the airport that they came from. And then geom bar is the argument that we have to do a bar plot. And then we have two arguments that we need to pass in. One of them is stat, and we have really two options that you're going to use. You're going to use count, or you're going to use identity. And so for this first one, we're going to use stat equal count, and then we're going to do position And this can also really take two separate arguments or two separate values. One could be stack, which would be a stack bar plot, or one could be dodge, which would be bars next to each other. So we're going to do position equal dodge right now. And so if we take a look at this, we can see again the month, and we can see the number of flights that we have across these 3 airports in each month. And we didn't have to do anything special to our data set. The stat equal count counts the number of observations that we have by the way that we are trying to visualize the data, and it presents that information for us. If our data set is a little more complicated, or if we just, for whatever reason want to do it manually, have a little bit more control, we can also do this in a slightly different way. So I'm going to call this new data set that I'm going to create just going to be flights bar. And this is going to feed off of our my flights data set, and we'll group by, and this will be grouped by origin and month name. And from here, we're going to summarize, and we're going to take the total number of flights, so num flights, and this is going to be equal to n. And so this is going to be just counting the number of flights that we have. So if we look at flights bar, we see that we have the origin, which would be the airport. We have the month name, and then we also have the number of flights. I'm going to change this to an S and reload the data set. And we also have the number of flights that that airport had in that individual month. So now we can plot this very similar data set, but we can see kind of the difference. So in this case, if we try to do the exact thing that we had before, origin, and then we do geom bar, stat, count, position, dodge. If we try to plot this, we see that the count's always 1, which makes sense because we have one value, right? We have one value of the num flights, one value of the airport at this month for each of the airports in each of these months. And so the reason why we created this data set was so that we could have just this count of the number of flights if we wanted to access that information for something else. Now we have that information inside of a data set. So all we have to do here is we have to specify what we want our y value to be. And so if we just specify what we want our y value to be, which would be this num flights value, and remember I changed from this, I added the s at the end. So we can't just do this though, because the stat count can only have an x or a y. So this is where we need to use stat equal to identity. And so if we run this and we run that, we see that these two plots that we have are the exact same values. We just see that the y-axis label has slightly changed. And again, if I want to change this so it's a stacked bar plot and not a side-by-side bar plot, all I need to do is change position to position equals stack instead of position equal to dodge. All right, so now that's bar plots. Really quick treatment, I know, but hopefully that's helpful in getting you started on the bar plots. So now what we're going to do is we're going to look at the days of the week, and we're going to make a histogram for the days of the week. So let's call this delay DOW, and we're going to take this from our my flights data set. And what we're going to do now is we're going to take the date as .date, and this is coming from, if we just look at our my flights and we look at time hour, we see that we get this date string here, and then we get the time stamp here. So we don't need the timestamp, so we're just going to pass in as .date to time hour, and then what we'll do is from that we'll grab the day of the week that that date corresponds to. So we'll do weekday. And then inside of LuberDate, we have a wday function, and we can pass in our date there. And so if we take a look at, let's just do a table, delay DOW, and we look at weekday, we see that we get the weekday numbers, which could be useful. I prefer to have labels for this case, kind of how I mentioned how I think the labels just look better as month names. So all we need to do is specify inside of this label equal t, and then we can run this table again, and we see that we've got Sunday, Monday, all the days of the week actually labeled as days of the week. All right, so now we can go through, and now we want to be making a histogram. So we'll ggplot this, and we'll do our delay DOW data set. Remember, passing in our data set as the first argument, and then we need aesthetics. And for a histogram aesthetics, all we need to pass in is an x argument. And so what I'm going to do is the ARR time for the arrival time. And we're just going to look at a histogram of the arrival time based on the day of the week. And so we'll do geom histogram. And I'm going to specify a bin width here of 25. And that's just an argument to change how wide this is. So if I change this to a bin width of 10, We can see that. And then a bin width of, say, 50, we see that these bins get a little bit wider. These bars get a little bit wider. So I'm going to move this back down to 25 here. And so we've got this histogram, and this histogram is plotting the arrival time. And so it's not really doing anything with the individual days of the week at this point. But what we can do to help show the individual days of the week is something called Facet Wrap. And so what Facet Wrap is going to do is it's going to create separate plots by the column that we pass into this. So, just to visually kind of show it instead of explain it, if we pass this weekday column in with the tilde specified before the column name, and we plot that now what we see is that we actually have the histogram broken down by each day of the week. And this is really all just now within one easy to see plot. I don't believe doing the arrival times is really the best way to kind of look at this, but you can see there are some differences. We see some higher peaks on Wednesday than we do on Saturday around 10 a.m. Just for example, we also see maybe there's fewer flights happening just after 5 on Wednesday than on Sunday. So there is some information that we can glean, but again, this really is just to show how we can utilize the different functions inside of ggplot in order to visualize our data set. So that's how we can have a histogram presented either with or without the facet wrapping. And so this facet, just to recall, without facet wrapping, and then with facet wrapping. And so this facet wrap can actually be used on anything. This isn't specific to the histograms. We could, for example, have a line plot plotted by days of the week as well, and that would work just in the same exact way. We could do something by month, and that would also show a separate plot with only that information from that month within its little quadrant of our larger plot. Okay, so the final plot that we want to be making here is going to be a box plot. And so with this box plot, we're going to be doing the departure delay. And so if I just ggplot this with my flights, and we pass in an AES, and we want to do, actually, we're going to do the delay DOW because we have the day of the week there. And then we need to pass in our aesthetics. So for this, we're going to do weekday. And then for the Y, we're going to be doing the departure delay. And then we can do geom boxplot. And so this will take a minute, and then this should be fine. Sorry about the delay here, guys. All right, so we can see, this really isn't a great way to demonstrate a box plot either. I think this is far worse than demonstrating the facet wrap from before. So what I'm going to do is I'm actually going to pivot this, and we're going to use temperature instead. And so this lives within inside the weather data set. So once you load in the NYC flights 13 data set, all those data sets are going to be accessible to you. So this is the weather data set that comes within that package. So just taking a quick look at it, we see that we've got, again, the origin, so the individual airport, and then we've got the information on the days. And what we're going to focus on here is the temperature. And so what I'm going to do here is we can do this again by day of the week. So I'm going to create another data set called temp DOW for the temperature on the day of the week. And we're going to pass in our weather, and from that weather data set, we're going to just again create the date from the time hour column that's also within the weather data set. And then we're going to create the weekday. And this is going to be, again, just the W day. We're going to pass in our date. And then because we want the labels, the actual weekday names, we're going to do label equal true. So now that we have this data set, we can ggplot, pass in our data set. And then for the aesthetics, what we can do is we can do X equal to, again, we want to do the day of the week. And then for the Y, we want to do the temperature instead this time. And here we'll do a geom box plot. And so here we see that, we can see the box plot of the temperature across different days of the week. And, if we're over the course of an entire year, we really shouldn't see many differences across, the mean here of the temperature across the day of the week. It's a little bit colder on Tuesday, but, not statistically significant, a little bit warmer on Thursdays. So, if we wanted to have something that showed a little bit more differences across this, what we could do is we could pass in our month variable. And just to recall what our month variable looks like, we'll look inside of our temp DOW, and it's this month just kind of as a variable, or sorry, as a number between 1 and 12. And so if we pass this in here, what we're going to see is we have a continuous X aesthetic. And so one way that we can really easily kind of combat this is to just make this a factor instead of allowing it to be a variable. And so it's read in as a continuous variable just because, you know, it goes from 1, 2, 3, 4, 5, so on and so forth. But really, we don't want to be plotting it as a continuous variable. We want to plot it as a discrete month. We want 1 to be different from 2 and not kind of have 1 feed into 2. So when we change that to factor, we can now see that, okay, January, February, March, and then we see as we start to approach summer, the average temperature goes up. And then as we approach the fall, average temperature goes down. Same here as we just kind of swing from January over to June, the temperature begins to increase. So now that we've kind of run through briefly all of these different plots that we can do, let's go back in and let's make a couple of changes to some plots to just cover how we can adjust these plots to make them maybe look a little bit nicer. And so for this, just for ease of use, and it has colors and everything like that, I'm going to go back up to the bar plot that we made. And so inside of this bar plot, we can already see a couple of things we might want to change. Number one, we maybe don't want num_flights as our y-axis label. We might not want month_name as our x-axis label. So we can change those very easily. And so to change those, we have a labs argument here, and we can specify x, and then we want to just call this month. And then for our y, we want to just do something like number of flights. And so when we do that and we change, we see that our axes automatically change to what we had changed them to. And then we also don't have a title here. So if we want to add a title, we can use ggtitle. And what we want to pass in as a title for this would be number of flights from New York in 2013, for example. And then we can have this. And so we see that our title is now there. We have this here. We have our y-axis label, and we have our x-axis label. So one of the things that I know I struggled with a lot when I was just getting started in ggplot2 was I completely forgot how to center a title every single time I went to make a new plot, and I was constantly Googling it. So if that's you, it's just one of those things that, you know, you'll eventually kind of catch on to it. So what you have to do to center the title is it's a theme argument, and the argument that we want to actually pass in is plot.title equals to element_text, hjust for horizontal just, equals to 0.5 to get that over into the center. So now we have a title that has moved from being left adjusted into being center right in the middle of our plot. So now we've got our labels, we've got our plot title. The other thing that I personally like to do is I don't really like this gray background here. And so I'm going to actually change that. And so there's two that I typically kind of go through, which is theme_bw, which still kind of gives you the appearance of a plot here. So this kind of gives you the appearance of a plot here. And then there's also theme minimal, which kind of just removes that border, and it's kind of clean. I kind of like the theme minimal, so I'm going to keep it there. And one of the things to keep in mind with something like this is because that is like an overriding theme argument, you always have to put that at the top. So we notice that the title went back to being left adjusted when I change it to this, and our adjustment of the plot title comes after our assignment of the theme. We see that our plot title now stays. So the other thing we might want to do is we have a legend here that says origin, but if you don't know what the data set is, origin might not make any sort of sense. So we can change that. And the way that we're going to change that is with scale, fill, and then I'm going to use manual here, and we're going to do a name of, we'll just call this airport, right? Insufficient values. Okay, so we'll just start with discrete for now. Scale, fill, discrete. And then this is an airport. And the reason why I was saying that I was going to just use scale, fill, manual is because what if we also wanted to change the colors of this? So we changed the label to airport, but what if we wanted to change the colors of these individual airport bars so that, you know, they fit the color scheme that we were looking to do? And so what we have to do for that is we can do scale, fill, and I'm just going to, again, do manual here. And I'm going to set the name equal to airport. And then we have this values argument. And so our values argument is going to take in a vector. And so we could just put in the values that we want. I'm going to also put in what the individual titles are. So like EWR, and we'll call that Firebrick. And then we'll have JFK, and let's just, I don't know, Cyan. And then we have LaGuardia, and let's just make that dark green. Okay, so now that we have this, I'm going to delete, I'm going to actually just delete, not comment out, our scale fill discrete. And when we run that plot there, we now see that our Newark Airport is Firebrick red, our JFK is cyan, and LaGuardia is dark green. Cyan's kind of abrasive. I'm going to just change that to a yellow. Still kind of aggressive, but a little bit better. So there's how we have control not only over our axes, but also over the title, the legend title, the individual colors of our plots. And notice here, if we change this from stack to dodge again, we can have a stacked bar plot and then very easily have a, I can't think of a name for it, just a bar plot with the bars next to each other instead. So that's really kind of the core of this crash course here. I'm going to cover one more thing, which is just how do we actually save these plots? So let's say I wanted to save this plot here. I have it the way I want it. I'm going to change that back to the stack. And I have it the way that I want it. And now I just need to save it. And I don't want to take a screenshot of this here. How can I actually save this? So there's two ways. The first way would be doing something like PNG. And so here I'm going to save this to just a folder called test. And I'll call this stacked.png. And then after we assign that, we need to also put dev.off at the end. So then we run our PNG, and then we run our ggplot, and then we run our dev.off. And then if we go and we look inside of this test folder here, we see that we get this stacked PNG file that's within our test folder. The other way that we can do this is with something called ggsave. And so with ggsave, we can also specify, the file name here, and this will just be, again, test, and then I'll do this as a ggsave.png. And you see saving as a small image, and we take this here and we look at our ggsave, and we've got our information. There's no background to this, and the reason there's no background is because of the theme minimal. But we could also change this based on the theme that we're using. So let's do theme BW. Let's do that, and then let's run our ggsave again, and we see our ggsave, and we see this here. So there's couple of different things that we could do to adjust how the ggsave looks. I haven't had to save plots in a while, but I tend to use the PNG version instead. But that's basically a crash course in how to use ggplot2. So the one thing I'd ask of you is if you made it all the way through to the end here, where you now feel like you've got some sort of skill set in ggplot, if you could subscribe to the channel here and like this video, that would be excellent to help keep me motivated to making videos to help you learn R and become an R expert. And also, if you prefer this longer form content to the shorter form content or vice versa, please let me know in the comments below. I'm trying to figure out what the best way for me to produce content is to help everybody, improve their skills in R. So any feedback is really valuable, so I appreciate it. So I hope this crash course in ggplot2 was helpful. If you have questions, as always, please let me know in the comments below. I look forward to seeing you guys in the next one.